Last time I started to deploy the ONNX model in C++, I mean in anomaly detection. And as you can see, this is the result of Python, and this is the result of C++, which is a bit, let's see, different. There are several defected, which is not also defected. And I will just show you the mask, or let's say a binary defect of the image. And you can see there's somehow in a Python or also in a C++. But the next step, if you could let's say investigate why the C++ and Python is different, and you can also make, let's say, a pull request if you already find. So what you should do is just compare the result, the input to the Python, and also the features. Maybe you could save it in a numpy array, and also this one here you can save it in a file or a numpy array, and we can, let's say, start to compare. But let me just show you how did I get this results. I'll just close this. What you need is in the beginning you need ONNX, of course. I already show you last time, and now we need to use OpenCV. The OpenCV, you just need to install this one here. It's just extracting the OpenCV, and I will just show you how it look like. So this is OpenCV tools. Hey, so this is after the extracting the AXE file. Now let's back to this, and I have added the directory of the OpenCV to the build, and here I have to include the include directory and also the libraries. Here I have added two different files. Indeed, it's three. One, it's the header file, and the CBP, then to detect. This one here, it's old, but let's just keep it like this, if in case we have some issue. And here, let's see, this won't work unless I have to copy the DLL to the binary file. So you can see this one here, exa4 binary, and we need to copy this for the debug and this for the release. So, but we need to copy this manually to the directory, to the output directory of the OpenCV. For example, here we need to copy it here. But this command here, it will copy this automatically, and you don't need to make let's say, take care of this. And here we need to link to the library that we have to use. So if you use different version of OpenCV, try to change this one here, and also here. Okay, so now let's just jump to this header file. What I should have in the header file, it's similar to Python. You need a config file. I mean, let's say a config, it's not a file. It's just a struct. And here you have to give the model, I mean the path, the directory of the images, the output directory, and this is the threshold, and here the main and standard division that used in Python itself for the ImageNet. And here the result, I need the score, heatmap, mask, anomalies, and here this is adding, just to add number of anomalies, let's say pixel detected. Here's the ratio of the defected pixels related to the image itself. And here's the image list that I will just read them in a list and read one by one. The processor, I have to add preprocessor, which is similar to the C++. I hope so. And here, this is the constructor, and this is the function. Now we have to add ONNX model. It's just adding the parameters to the ONNX model. Here's we have to run. For that, we have to add somehow post-processing. After the detecting, we need to let's see, applying the threshold, applying the blurring and everything. So this is the pre-processing, after the pre-process. And here, this is the visualization. It's not, let's see, exactly as the Python, because in Python I have three stacked, four images, but here I just detected the only the defected image. Let's see the last result, and this is the private stuff. And here, this is the implementation of each function. And of course, if you have any question, just drop it down in a comment. I will reply. And in main, I have to include this header file. Include, of course, this one is easy. And here I have to add the parameter, the command line. Let me just clear. This is how to run, not Python. How to run. Okay, that before how to run, we need to, let's see, need to see how to build the system. So let me just delete this, and I have added these commands here, so you can see. Go to the directory of this project. So I'm in ONNX. You can see here. This is the ONNX, and I will just build the code. It will generate a build directory, and after that we need to build the directory to get the exe files. So you can see here I have release, config release. Because why I have used release? Because I'm using release DLL. If you are using debug, you have to change it to debug. Or maybe we can also update the CMake file that it can detect which is debug or release. This could be maybe, if you just need to do it, it's easy. And now let's build. And finally, let's just run this command here. I have here this is the image, and you can see in the beginning it has 74 milliseconds, which is indeed high. In Python it's super fast indeed, but this we need to check why it's that. And here's the number of numerous pixels, and this is the ratio, and etc. And for the result, we can see the results in directory here. Now let me just maybe delete this and do the run again. You can see it's running.